Hi, welcome to ToddFun.com, and this is going to be a hopefully quick teardown review of this CSI 75W programmable soldering station, the one I just did a review on from Circuit Specialist. I don't want to spend a lot of time reverse engineering it or anything like that. I just want to give you a look inside and see what's inside in general, but not in detail. And then also kind of compare that to the circuit that's in here, which is the analog version, my Hakko 936. We might even look inside the wand too, because there's going to be some sort of a sensor in the wand that's tip sensing. I just want to get that teardown out there because some people like to see inside, and then some high resolution photos. So those of you that want to kind of have a look at what chips and stuff might be in there, maybe we'll get a good look at them, and you can look them up and decide for yourself what's all going on from what I can at least show you. To the bench. Let's start with looking at the Hakko, because this is just an analog, simple analog one. I took the screws out already. Cover comes off. We're not left with much really. We got essentially power comes in the back, goes through a switch, and then a fuse, a 2 amp fuse. That's easy enough. It's even marked down there. A really nice looking 24 volt transformer. So this is a 24 volt AC comes in, 24 volts comes out. So you get 24 volts coming to the circuit board here. There's also, looks like there's a ground, earth ground here, and then chassis ground coming over and providing chassis ground to your circuit board. So all the goodies is underneath this. So I'll see if I can get the set screw off and see if we can pull this panel off and take a look at the circuit. There's a little cowl plug right here. When you pop it off, you can see there's a little pot potentiometer underneath there. This came off with an Allen wrench, of course, but this is snapped on and we have to unsolder that. So I'll get out a different solder iron, take that off, and we'll be back. Interesting stuff. Keeps your fingers from getting overheated. Of course, the portable soldering iron that was given to me by IsoTip. Come in handy because I don't have anything else plugged in. Gets plenty hot to do a good job. Got kind of a wheel on the back you can spin to push it in and out. Got to kind of pull it though without burning your fingers. So you can hold it so you can yank on it. Okay, I got that solder off of that, and so now this will pull off. And what we're really worried about here is just the quality and the general, essentially, topography of how is it driving the iron, you know. And it looks fairly clean. I'll put some high-res pictures with the blog posting. If you want to see the blog posting with the high-res pictures, go to the link in the show notes. And that's the back traces. It is a one-sided board. It's sort of a Farnellic kind. It is made for Hakko, and it is the 936, so the board is for this. It's very simple. This is the LED that's going to tell you when it's actually drawing current through the Triac. The Triac is what's switching the power on and off from the 24 volts here. What's controlling the Triac is this, I believe they call it a 0 volt switcher. It's a Triac Driver. Let's get a good view of that. There you go. This chip right here where my thumb is a quad operational amplifier, a low power one, and the reason for the operational amplifier is for the fact that it's going to be sensing the tip temperature through a couple of these points. And then also you need an operational amplifier for when you're working with this offset voltage, or your offset pot here for calibration. Then you got the temperature you're setting here, then there's going to be another op amp used there. There's going to be an op amp then going from those into your Triac Driver, and there's another op amp used for, so the fourth op amp is going to be for a voltage reference generator, for essentially a buffer for a voltage reference generator that these devices then use. This circuit over here is creating the plus and minus VCC to drive your op amps and your chips, but the 24 volts is used directly from this transformer through the Triac AC wise directly to the tip. And that will be the same in the CSI. The CSI will be the same. And so there's nothing really complicated here. Very simple, very clean. It's been reliable. I've had this for, well, probably as long as the date code says. So 97, yeah, probably 97. So this gives us an idea of what a simple analog version is, and we'll be able to compare that to what we find in the CSI soldering station. I was able to do that with my ISO tip cordless charger that I reviewed a few weeks ago. Comes in very handy. As you can tell, it's still the New Year's Eve because fireworks are going off. That label comes off. Don't like that. Oh well. Works great. So this is the inside of the Hakko iron, pencil iron. It's got a fiberglass PCB board and not too terribly well soldered. I mean, as far as there's lots of crud still on it. We have coming in the green wire here goes all the way up to this sort of a ground spring up at the top, which is what's going to compress onto that. That's just shielding the outside and making sure that you can say the tip is grounded. Then the blue and the red coming in here, those are going to be the heater wires because they directly go off on the PCB board to these two blue shielded wires they go up into this ceramic heater core. And then the black and the white, they're the scents, and they go onto this side of the PCB board and into these red ones. And then if you follow the reds up inside, it's essentially just wrapped around the ceramic core here, and that's going to be the temperature sensor for the probe tip right there. And that gets fed back in and then read and amplified and cross-referenced from the cal and what you want and set and into the Triac Driver and off from the Triac Driver out to the 24 volts up to these two blue wires, and that's how she keeps the temperature set to what you got dialed in. So this will be the same in the CSI, except for there's going to be some sort of a ball sense thing where you tip it and there's going to be like a little ball bearing that drops in like a little tube. That a ball bearing switch is basically what they are. That's what I think it'll be. So we're inside of the CSI Premier 75W soldering wand, pencil iron, and the wiring is very much the same. It's also a fiberglass board with about the same quality soldering. It's got almost the same wires. It's got two wires for the heaters, which are going to be, in this case, in blue, and two wires for the temperature sensor in red. This high temperature shielding, because it goes up into the ceramic heater. I call it asbestos, but it's probably not asbestos. It might be. I don't know. It's high temperature shielding though. You find it in coffee pots and all kinds of stuff where there's heat. And the only thing, there's one extra wire. In this case, there's one extra wire for this, which is the ball switch. And there's actually a little ball bearing in there. And when you tip it, a little ball bearing will fall down from this chamber in this black sheath, which is just looks like some heat shrink wrapping on that to insulate it. And that makes contact between the feed wire and that wire, and then of course then the electronics can sense that this has reached at least enough of an angle to where that ball bearing can roll forward, and that's what wakes it up from sleep mode. So quality's fine, nothing wrong with that so far. So let's get inside and see what differences in quality of workmanship we see inside the CSI Premier 75W. Yes, it's definitely rebadged. I've already had some people comment on the other video of the review that this is out in the wild with other makes and models and brands because it's a rebadge. But yet everyone's reviews that I've that posted back said they liked it, so it seems to be a quality rebadged soldering station. But the thing is, circuit specialists can buy these in large quantities, and when they do so, they can feed back to whoever they're having them produced by in China and rebadging them, saying, make these changes, make this quality, or the stuff's coming back. And so they have a little bit more purchasing power and say in what keeps with their feed. And that's how I think circuit specialist keeps their customers a little more happy is they basically say, return it if it's bad, and they'll deal with the vendor themselves. So I got the screws off the bottom on that, so this should just lift right up, just like the Hakko. And let's see, we got mains coming in with good strain relief, bolted down. We got a slightly different looking on-off board with a 2 amp fuse that's through hole. Just a little piece of fiberglass board. Mains coming in and coming out of red, and then it looks like we also have mains coming off the blue and going. So this is kind of European colors cord coming in, actually. That's funny. And then they both go to red because the two sides of the bottom of the transformer is for the mains, and then it looks like a fairly decent main transformer. It's decent size. It's got 2 outputs, so there's 2 taps. There's going to be a 26 volt tap coming out of the blue, and something slightly smaller for the yellow. Judging by what's going on here, you got the 26 volts coming up to the top, where it's controlling it with that. Looks like it'll be a Triac in there again. The 24 volts is going down, and that looks like it's going to come over and go through some sort of a rectification regulator here for running some chips. So we'll pull that off and take a look at it. So this is going to be, oh, I don't know, I suppose it's be about an 8 or maybe even a 12 volt a tap. Well, that's good that these are just clip-on. That's pretty nice. The two power taps are just clip-on. Unfortunately, the chassis ground, which goes to the center terminal of our wand, is not. So we'll have to unsolder that real quick, just so that we can just have. I mean, it's just a nuisance to deal with this board with this one little ground wire on there. Let's see how quick a work I can make of this with my ISO tip cordless. Pretty quick. So we can push this away. There's not much else going on there anyway. So I can see I kind of want to get this board off of this face plate, and there'll be 2 screws here. There'll be this retaining nut for the collar on the rotary encoder. Unfortunately, in this particular model, this iron pencil wand goes onto here, and that's soldered into that, and it's got a retaining screw on the back, retaining nut on the back. So that means I'm going to have to unsolder this, and then we want to get the board off completely for 2 reasons. We want to fully be able to evaluate what we're looking at, and the second thing is I can see already that there's a sandwich of the display through here, and there's this cover glass. I'm really curious, if I take off that cover glass, would I have a better display? There, so we got this unsoldered, and it was a bit of a chore getting it all off, and I got all the screws off. And so this is the panel, and this is the thing I want to pop out if this display looks better at different angles without this blue screen. Let's see. Looks like it's a 2-layer fiberglass. It's looks like I had a couple of problems with the pads. So what that means is these 2 rings came off, but they don't go to nothing on this side. This is the center ground, and this one didn't go anywhere. On the other side, it doesn't go anywhere. And being it's a 2-layer board, that just means I have to solder back onto that ground pin on the other side, and then I have to make sure that this inside ring gets solder right here. So I'll have to come in from the side and make sure I get some solder on there if I can't flow solder down in there real good, because without that plated through hole it'd be a bit harder. So it took a lot of heat to get those big connectors didn't want to come out easy, and it was a lot of challenges for that. Okay, so let's just take a look at what we got. Interesting enough, we have a couple of potentiometers inside which are not accessible from the outside. That's very interesting. We have a microcontroller here. It's crystal, 5-volt regulator. So obviously this lower voltage tap is coming in here, and you can kind of see the traces down here coming around. to the 5-volt regulator, so you got power for these ICs. And then up here, the bigger, that's kind of crooked, that's poorly soldered. You have the 26 volts AC coming in that's going to go through this Triac. This is interesting. This is an opto isolator, so that this micro can control this with isolation to the gate of this Triac. Okay, but you can see there's another one here. It's even marked the same, MOC 3041, and that's the same thing that's silk screened right there, MOC 3041. So there's two ISO operators, one's not populated. There's two Triacs, one's not populated. The question is, this one goes to this pin, and this one goes to that pin. That's very interesting. So these are the gates coming in, there and there. And so they go around here, and both of them come around to the opto isolator. So it looks like you got two opto isolators with the ability to have two separate Triacs going to two separate pins. One of them must not be used. In fact, yeah, one is definitely not used. Okay, well that just means that this control board can obviously drive maybe a bigger iron that has two heaters, and hence you got like up to a solid on 8 amps. Now this Triac BT137 600E. So that's a Triac with a sensitive gate control on it. And that makes me in question why they have an opto isolator, other than of course it's just standard practice to isolate this from the micro. But this, the fact that it's a 600E, it's a 600 volt E for sensitive gate control, which means this micro can more than happily control this gate directly without an opto isolator. But then, you know, then they want the isolation, and okay, fine. So you put it in. 2 cents, no big deal, I guess. Well, maybe 10 cents. So obviously this board can do a different type of iron that is got a second heater in it, or ability to have a second path, because this is one Triac and this is the other Triac. Okay, so then here's a buzzer, because it does beep at you. This crystal can run, this micro can run a lot faster. I think it can run up to even 20 megahertz if I remember, because I did look this up. And this is an 8 megahertz crystal. There was a lot of features in that micro. I wonder if I can get a good view on that micro. I get a pretty good match looking up that micro. It comes out to something that's 48 QFP package with 32 kilobytes of flash, 2K of RAM, a couple of UARTs, I2C, a serial peripheral interface, an ADC, 10-bit even, believe it or not, in that. An LCD screen driver. Well, that makes sense. There's an LCD on it. It probably uses it for that, if it couldn't just drive it with its own software. Up to a point. At any rate, 40 GPIOs and timers, some 8-bit timers. Yeah, so quite a powerful little chip there for controlling this. They didn't skimp on the micro. This particular device is it's an ST micro. Let me see if I can get it. Yeah, you can see it's an ST micro, and it looks like a G7411. You know, I couldn't find anything on that. I just couldn't. And this, well, definitely not. I couldn't even get that with a microscope hardly. But I think that's cross-referencing to a double EEPROM. I think it's just storage, and it even comes off the micro as kind of such. So it's probably storage for your settings. So when you're clicking your options, I don't know why it would need to store. You would think it would be able to do it in the flash, wouldn't you? But if it's too much, or if they just make it easier, they just store it out to this double EEPROM, and it's just maybe simpler, I guess. I don't know. I don't work with a lot of microcontrollers like this, so I'm not exactly sure you could store it. I know I've had other Atmel devices, microcontrollers I've stored things permanently in memory with, but you only have a small amount. But you know, how much do you need to store a couple of presets and whether or not you want Fahrenheit and Celsius? I mean, it's not like this thing is data logging or anything, you know. So I don't know. Interesting. I don't know what this connector's for. Not a clue whatsoever. Maybe it's for a programmer, maybe for an in-circuit programmer. It would seem like if they're trying to save money, you would think they would leave that off, unless they do changes after this is already assembled. This is odd. It doesn't look like there's any solder on the LCD screen. Likewise, it seems like it's not much solder on these buttons here and here and here. These are the buttons on the other side, and as well as your rotary encoder over here. So there's not much solder on any of the backside. So what they've done is they've obviously assembled that last, or pre, I'm not sure, but at any rate they just wanted to solder it, so they just flowed solder in from the top, and you can see there's plenty of solder on the top, and because these are plated through holes, they just let the solder wick down through and make contact with these pads. Okay, as long as they're plated through and you get good solder on this side, which you can see there is. Likewise, there's good solder on all of these rotary encoders and buttons. And it would, of course, conduct through, and it would work fine. I guess I would just like to see, I'm just so used to seeing this side soldered better, but really, if it were the other way around, the solder would have to suck up and go from a trace over here anyway, so that's pretty standard. It's just odd looking, that's all. It's not necessary. The capacitors, well, they went really cheap with that, JWCO. That's a pretty off-brand. I found some information on it. They went as cheap as they could with these capacitors. There's no doubt about it. They probably went as cheap as they could for a lot of things. Yeah, they used STs here, and they use NXP over here. Next, so they didn't cheap on everything, and you know they use name brands for a few things. So I'll probably top off the solder on these rotary encoders and buttons and stuff just to make sure they're done. Now, see, I was originally thinking that this Triac was missing because I was thinking that this micro was controlling them together. And that way, if this thing was solid on 600 volts, it could go 8 amps solid. But it can go quite a bit more amps than that if it's just pulsing. But I thought because the tip on this was capable of pulling about 9.5 amps, I was thinking maybe they were ganging this up and that may still be true. I guess I didn't really look inside the wand. It could be that these two wires, even though they go out through two separate holes here, they probably go to the heater together. They probably tap together on the heater element on the inside of the wand, meaning that, yeah, they did have this designed for two opto isolators to be controlled and two Triacs so as to pulse them together, and if they're solid on, then you're dividing and you're getting 8 amps and 8 amps, and you're not going to draw that. You're not going to draw 16 solid amps through those two wires to that tip. But you certainly could draw up to 9.5 amps with the type of ohm resistive heating element that this has. So maybe they are getting a little bit cheap here by pulling down and dropping one of the control op amps and one of the Triacs, and just hoping that this isn't on solid all the time. It only would be on solid when it first ramps up, after which point it's going to be pulsing. So maybe they did enough testing to know that this was over-engineered, and they just dropped those two. Or maybe this second one does not tie to the same heater at the wand, but you think it might. I don't know, I mean, as far as soldering is concerned, it's not that bad. That chip is soldered on real well. I don't have any complaints about that quad flat pack being put down. That's being a bit crooked, and other than that, yeah, it's pretty decent quality. It's even kind of cleaned up pretty good. I mean, it's got a little residue over here, but it's not a filthy board by any means. I'm going to hook up and see what the screen looks like, and maybe I'll pop this out. Okay, so for the test, we should only need this lower voltage tap, because this higher voltage tap is just for the soldering wand itself. That's just the control through the Triac. So we should be able to flip this on and see if we have anything. Yeah, I mean that's the error message, of course, but now I wonder how it looks when you put this screen over it. It used to be horrible. Jesus, look at that screen. That's just terrible. That's wow. It's very much more readable without it. I wonder what it would look like if I pushed it back on the bench. Holy camoles, that's much, much nicer. That is just vibrantly bright. Not so with that in front of it. Yeah, I'm thinking I'm going to pop this out because that's got plenty of backlight on there. Looks amazing. My only thing is that if it sits behind here quite a bit, it's recessed. You should still be able to see it. It's just going to look recessed. Maybe that's what they were trying to avoid. But they should have used a clear plate then, for that matter. Here we go. We got it back together. We got everything plugged in. Let's flip it on. Wow. Look at that. I mean, this is with look at all that. I mean, when I did the review, I could not see this unless I turned off about 80% of the lights in the room. I couldn't see the display head on. And look at that. It's just as clear as can be with all my fluorescent lights on. And easy to see on the camera. And let's look at it back here. So at a normal viewing angle on the bench, it'd be back like that. And look at that, even with all that lighting, it's perfectly easy to see. It doesn't even look bad missing this little purplish thing. You can put it on and you can see it just I mean, why would you do that? I mean, I can see it at this angle, but it's difficult for the camera to see because of all the extra lighting I have in front of it. But with my eye I can see it, but with that, not only can the camera see it, I can see it. It's as bright. It's just bright and beautiful. So yeah, it'd be nice if that then screen was flush, but it doesn't. You can't even tell you mean just a clear cover and you'd have been fine. Just for crying out loud, make that a clear cover. For stupid. Well, that's the teardown of the CSI Premier 75W, as well as the Hakko 936. Learn a little bit about what's inside both of them and how they compare, how they have a different approach towards the control, one being more analog and controlled with just op amps and sensors, and the other an actual microcontroller. Surprised at the powerful microcontroller that was in there. It had a lot more power than I think they probably needed. Maybe they were exploiting the fact that it had the LCD driver built in. If that was important or not, I'm not sure. Of course, then having the other features that it came with, it just maybe when you get a small microcontroller like that for pennies, just throw it in there. And so what if you're not using 99% of what's in it? You're using the 1%, or in this case probably 5 or 10% of what it had. So it makes sense maybe in the end. Still a little thinking maybe they were engineering this thing to have 2 of the Triacs in it to control 2 heaters, maybe for a bigger wand, or maybe that's what they meant it to be and they just figured in the end just didn't need it. But it was interesting to learn about. It was really interesting to see when I took the display off how well the display worked. That's, if you've got one of these, take the display off. Take that screen off, and if you really want to cover, then just glue a piece of clear plexiglass behind it if that's what you want. But I don't want it. It looks great. So thumbs up if you liked the teardown. If you didn't see the review, in the show notes and at Todd Fund, there will be the link to the review of this soldering station. And I'm going to take a lot of high resolution photos for both of these soldering stations and put them up at toddfund.com. The link is in the show notes below. And you might be interested in, maybe you'll see or notice something or comment more on some circuits. So thanks for joining.